A spreadsheet is much more powerful and versatile than a handheld calculator. A spreadsheet can do everything that a calculator can do and much more. It can also display data in a much more meaningful way than a calculator can, even a graphing calculator. In this video, I'll describe the process of finding standard deviation using a spreadsheet. I'm going to describe this using a Microsoft Excel spreadsheet, but everything described in this video could also be done using Google Sheets or really virtually any other modern spreadsheet program. The problem we'll look at deals with the heights of 10 people. In centimeters, we're given the heights of 10 people, and what we'll do is use a spreadsheet to compute the standard deviation. To find standard deviation, we'll use two formulas. First, the variance can be described verbally as being the sum of the squares of the variations from the mean for each value in the data set divided by n, divided by the number of values in the set. In this case, there's 10 values in the set. In this formula, x1, x2, x3, and xn represent all of the values in the data set, starting at the lowest and going to the highest, although in this formula, having the values in order from lowest to highest doesn't necessarily matter. And x bar, which shows up in each quantity, is the mean. Add the 10 values together, divide by 10, x bar is the mean. Once you know the variance, standard deviation is very simple. It's the square root of the variance. We'll go through the process of having the spreadsheet compute all of the parts, all of the steps required to find variance, and then once we get the variance, we'll have the spreadsheet take the square root of that to find the standard deviation. Once we complete that process, I'll show you a shortcut that you can use to find the standard deviation when using a spreadsheet. Let's begin. I've set up an Excel spreadsheet that I'm going to use to help me calculate the variance and the standard deviation. I have the formulas for variance and standard deviation in the bottom right-hand corner of the screen, and I've set up a spreadsheet that includes the heights that were given in the problem. The first thing I'm going to do is find the value of n. N is the number of values in the situation, and here our data set contains 10 values. Once you have the values in Excel, if you highlight all of the values and then look down in the bottom right-hand corner of Excel, it has the count of the values, the number of values that you have highlighted. And in this case, that is 10. So the value of n is 10. Additionally, once you highlight all of those values, it will also tell you the average. It's labeled in Excel in the bottom right-hand corner, the average of the selected cells. That's the mean. That's adding up those 10 values and dividing by 10. It's 169.8. So that's the value of x bar, the mean, 169.8. Next, I'll calculate the variance in a couple steps. I'll have Excel do this step by step for me. And as I perform this operation, it doesn't matter how many values I'm dealing with. You can always go through this process the same way. Excel will be doing the calculations, and it will take the same amount of time whether you're working with 10 values or 1,000 values. So, I'll begin by finding the deviation from the mean for each value in the data set. And the deviation from the mean is basically how far away each value is from the mean, the difference between the value and the mean. So to find the difference between 151, the first value, and the mean of 168, what I'll do is type an equal sign to begin a formula in Excel. And that would be the same thing that you would do if you were using Google Sheets or most other spreadsheets. And I'll type the value, I'll click in cell A5. And on the screen it shows me just an A5, but that indicates that it's going to take whatever value is in cell A5, and then I'll hit a minus sign because I'm going to subtract the mean from this, and I'll type the mean, which is exactly 169.8 here. When I press enter, on the screen it shows, and I typed 168.8 accidentally, it's 169.8. After I press enter, it shows on the screen negative 18.8 in cell B5. That's the deviation from the mean of the first value, 151. I don't have to type this formula 10 times, or if there was 1,000 values in my data set, 1,000 times. Excel will copy this formula to as many cells as I would like. And that can be accomplished by moving your mouse over the green rectangle in the bottom right-hand corner of cell B5 once it's selected. Once you move your mouse over that green rectangle, the mouse changes to like a black plus sign. If I click and hold and drag down to the last value, to the cell beside the last value in the data set, and then let go, it has copied the formula to each of those 10 cells. The top cell says A5 minus 169.8. That's what I typed originally. The second cell, notice, says A6 minus 169.8. The second value in the data set is contained in cell A6. So these are all the deviations from the mean. In the variance formula, each of the values in the numerator of the variance, each of those deviations is squared. So that's what I'll do next. And I already have a column labeled x minus x bar squared. And what I'll do to accomplish this is I'll hit the equal sign again to tell Excel that I'm beginning a formula. I want to square the first deviation from the mean, the negative 18.8, the deviation of 151 from the mean. To square that, after I hit the equal sign, I'll click in cell B5. The squared key in Excel and in most contexts when you're using technology can be described as the caret symbol. If you press shift and the 6, will give you this symbol. And then I'll press a 2 there. And what that will do for me is it will take whatever value is in cell B5 and square it, raise it to the second power. When I press enter, I see that I have 353.4 there. That's the square of the deviation from the mean of 151. Now if I click on that cell again, move my mouse over the green rectangle in the bottom right-hand corner of the cell, hold the mouse button down and drag it to all 10 values below, it will copy that formula to each cell. In cell C5, it took the square of negative 18.8. In cell C6, that's the square of negative 10.8. If you look in the formula bar, you can see it's B6 squared, the value in cell B6 squared. So now I have a list of all of the squares of the deviations from the mean for each value in the data set. The numerator of the variance formula adds all of those up. It sums all of those up. So what I'll do is I'll put that sum below that column in cell C15. Excel can do that for you with a formula called sum, S-U-M. I'll hit the equal sign, type S-U-M, and then open a parenthesis, and then highlight the cells that I want to sum up. Highlight the cells I want to add up. In this case, those are all the cells from C5 down to C14. Once those cells are highlighted, I can press enter, and it will give me 1176, the sum of all of the deviations from the mean. So that would represent the numerator of the variance formula. That's the numerator of the variance formula. I have to now divide that value by n. On my Excel spreadsheet, I'm going to click in cell F4, and I'll type variance equals, and I'll actually compute the variance and place it in cell G4. I'll compute the variance by taking the value in cell C15, which was me adding up all of the squares of the deviations from the mean. and I'll divide it by n. I'll divide it by 10. So with cell G4 highlighted, I'm going to press the equal sign. I'm going to click in cell C15. That's the numerator of the variance. And then I'll press the slash, the forward slash, which represents division. And I want to divide by n. So now I'll click on cell B1, where I've stored the value of n, the very beginning of this process. I'll press enter, and I can see that the variance is 117.56. And by the way, this value is just about filling up this entire cell. So if there were more decimal places than just these two, it would round them off. It would round it off to 0.56. If I click between cell or column G and column H, click my mouse button and drag over to the right and make that cell larger, I will be able to see if there's more decimal places. In this case, even though I've made the column larger, it stayed 117.56, so I know the variance is exactly 117.56. So that's a rational number. The standard deviation is usually irrational because it is the square root of the variance. So I'll find the standard deviation by simply taking the square root of the value that's in cell G4. Excel has a formula for that. I'm going to press the equal sign and then type SQRT. Those four letters will take the square root of whatever cell I click on after I open a parentheses. SQRT is the Excel function for square root. So after typing equals SQRT and opening a parenthesis, I'll click in cell G4, the cell that is storing the variance, and press enter. And this gives me the standard deviation, 10.843. 10.843. And again, this is an irrational number, so as a decimal, it will never end or repeat. If I wanted to see more decimal places than just 3, I would move my mouse between columns G and H until it turns into a double-headed arrow pointing to the left and right. Click and hold and drag to the right, and that will display more decimal places in the standard deviation. Nice thing about using Excel to compute the standard deviation in this manner is that if one of the values changes, everything else, all of the work, will automatically update. For example, if the tallest person in this data set, 190 centimeters, if their height wasn't 190, if it was actually 200, I could change that value to 200, and you can see how everything changes. You can see how the variance changed and the standard deviation changed. It's got larger. If I change it back to, because 200 is further away from the mean than 190 was, if I change that back to 190, the values return to what they started at. So that's the process of using Excel to compute the variance and the standard deviation step by step by step. This is the same way that you would do it if you were performing this computation by hand or with a calculator. And now that we've done that, I'll finish this video by showing you that Excel actually has a single function to find the standard deviation that will do all of these steps at once. And that function is, and I'm going to click here in cell G7, and I'm going to press the equal sign, and then I'll start typing STD, which stands for standard, and then DEV, EV for deviation. And you can see that there pops up below 4 or 5 or 6 functions that have standard deviation STDEV in the name of the function. We're going to pick the one that says STDEV.P. And what that stands for is standard deviation when given the entire population. So if I am assuming that these 10 values represent the entire data set, if you were actually going to use a standard deviation to make assumptions or to solve an interesting complex problem, you would need a population of far more than 10. but for the purposes of this example, we're using a population of just 10. And what I'll do after I type the formula stdev.p, I'll open a parenthesis, and then I'll highlight all of the values in the data set. Those are in cells A5 through A14, and the parentheses, and press enter. You can see that I have the 10.84, the same standard deviation that I got when I did it step by step by step. So Excel does include a function, which I have highlighted here in the formula bar, for computing the standard deviation automatically. But it is good to know how to use an Excel spreadsheet to manipulate numbers and to go through the process of finding a mean, a variance, and a standard deviation.